My name is Tobias Schrag. I'm Professor for Thermodynamics at THI, Technische Hochschule Ingolstadt, and I'm also leading our Institute for New Energy Systems, where we dive into new technologies for renewable energies. In Ingolstadt, there is the in-campus site where Audi and the city of Ingolstadt has built up a really very interesting new systems for low heat district heating system, and to integrate a storage into this system is a really scientifically and also practically very interesting thing to do, and so we join all together to make this happen. So in INTERSTORES we have two demo sites, and these are two thermal storages for which are very different, and it's going to be in Finland the biggest thermal energy storage worldwide. And in Ingolstadt, it's low temperatures, and it's also a cooling storage. So talking about cooling storage, this is a really big cooling storage, and making something new is always a challenge, and we are learning a lot, and our task is really to steepen the learning curve and also transmit everything that we are learning in this project to other people, so we can replicate it easier. We are mainly active in two work packages, work package 4 and work package 6. That means 4 is the integration of the storage into the energy system. So is it best used? Is it charged, discharged, and we develop the charging controller therefore. And in work package 6, that's very much about the transfer and the economic assessment, that it's not white elephant built only once, but we want to replicate it all over Europe. So both storages are there to have renewable or waste heat energy systems, so to reduce our CO2 emissions, and that's what we have to do as a human society. Yeah, that is the point about any storage. Is nowadays renewables are the cheapest form of energy, but they are not always available. So we need storages to make them available all the time, and these storages have to be cheap. And that is why we have to learn more about building new types of storages. So that is how, in the end, we're reducing fossil energies, because we store renewable energy or we store waste energy, then in times of demand, no fossil fuels are needed. Thermal storages are all over integrated in the energy system. The point is about seasonal storages, so large-scale seasonal storages, and that is, in principle, it's a simple technique, but the problem is an economic one, because if you use a storage only once a year, maybe you're using it for 50 times a year, but every cent of investment has to come back, and it's only coming back once a year. Different than a daily storage, where you earn every day that you use the storage, you make use of it, and your investment is counterbalanced by a daily use and not only a yearly use. That is the challenge. I'm very interested, these low temperature thermal source networks, we call it, or fifth generation, where you don't have really hot water that you can use as heating, but it's a basis for heat pumps. This is a system that we will have much more, and because we will have much more heat pumps, and we can't always rely on air source heat pumps. And I expect this to be really a big part of our energy future. And to integrate storages into this is a special challenge, because you have a low temperature range, and this reduces your storage potential. So yeah, how to tackle this? That we have a system that is very important, that we're going to see much more often, and has the hard challenge to integrate storage. Definitely, it will be different for the Finnish storage case, which is a very, very high temperature. And if this succeeds, this will be a role model for almost all district heating systems that already exist. And we will much more see systems like that integrated into completely existing district heating systems. While the Ingolstadt case is different, there I expect that these thermal source networks, these low temperature district heating systems, they will develop in the future, and we will see much more of them. And we will try to make them happen with some storages, because they are better than, but that is something that has to be created newly, and so we don't have an existing system where the storage can be integrated. We will have to have new systems, and then we will see when and where a storage is feasible.